Just some random thoughts on looking at the difference method. You said that you would have trouble with RONs because the supernova is right near the core. So if we load up the patrol image and the reference image, I can then go through the process here. We go align and do that, and what that does is it takes his image, which one it's done. I think it's taken the ref, or I can't remember which one it's done, but it's moved one of them. So this is you can see there's a dark border around the side there. You then go to process pixel math and we say let's have the reference as image A, the patrol as image B. What it does is it always jumps. You can't automatically get it to move the black point over, but if we do that and change the screen stretch, you can see that there is a very definite black blob in the middle there. That's with 75% here. You can play with those. So say okay, let's have a look at that. Now there are small black things in other places, and you obviously got the big black region around the outside here, which is not present in both images. But if I go, Maxim has got a graph window option, and we can set it to area plot and drag a box around the middle, and we get something like this. So there it's showing the stars. These stars are the peaks, but we want to look at the low areas. So if I look at the average brightness, this is down here where it says average. If I go into spaces between stars, it's saying something like 360 as the average. So I don't want to look at anything that's brighter than 360. So if I go to view graph window and go to settings and say let's have, we don't auto scale it, let's have the minimum as 0. No, that'll be all right, minimum 0, but the maximum of about 360. So it will then produce something like that, and we can see there's a very definite dark bit going right down to 0. Few small pixels, single pixels, are hitting 0 as well. But if we zoom in on the area of interest there, you can see that's definitely quite negative. Now it would have gone below 0, but obviously Maxim is saying you can't go below 0. So I was thinking what might be a cunning plan would be to add something to every single pixel, which would raise it upwards well above the 0. So then when you do the subtraction, you can go truly downwards as far, you know, whatever that would be. That looks like that's 300. I'm guessing that in terms of the shape of the curve, it might have got down to about here somewhere, about minus 200. I could look at the ADU values and do a little arithmetic and see what it really would have been. But that might be something to have a look at. Obviously, if there's very thin single one, it's quite difficult to try and find what is doing that, because we don't really know where it is. If I draw, let's have a look, let's move this around. Can I draw the box? If I go to the edge, yep, I can wander around. Oh, there's something that's gone. Yeah, I don't know what, that's a bit difficult to see that. I think what I might do is zoom in. Oh, there we are. Look, there's a very dark pixel there and another dark pixel there. And if I look at the values, yeah, that goes to 0 and that one goes to 0. But clearly a single pixel going to 0 can easily be rejected. Quite often around a star you get a little bit of a black dot. It seems to be in the bottom right hand corner of each star. This is the alignment not being absolutely spot on, but I think we can see that finding the biggest negative values, or the greatest negative values, and if they are of a significant circular shape, then that is going to be a variable star or a nova or a supernova, something along those lines. There we go.